Okay, so this is the third unit which is just division, including long division and division word problems, interpreting remainders, and so on. It was by far the longest unit. It took about 4 weeks. And just the understanding long division part took about 2 weeks or so, I would say. I guess the goal of it was to have kids have a real understanding of like why the algorithm works the way it does for long division, and also just to create an algorithm that made more sense, or adopt an algorithm that made more sense for kids. And I think one thing that's been really cool about like the results that I've seen is that kids have a much better idea of when their answers are wrong. That they really have an understanding of like, I guess, like what the common mistakes are, or that they might make when they're doing long division, and sort of the random mistakes that kids might make with like bringing down too many digits, or simple multiplication errors that might result in kind of having weird remainders, or subtracting and having a number that's like bigger than the divisor, things like that. Kids like really have an inherent sense of like when that's happening, and they like immediately know that something is off, and so even if they're not able to like immediately identify like what exactly that problem was, they know that something is wrong. And I feel like they felt so detached from the old algorithm for long division that they didn't really get that understanding of when something was off. They were just kind of applying steps and didn't really like understand what it stemmed from, I guess.
Can you talk about some of the other skills too that it built about maybe place value, kind of being able to do quick multiplication with large numbers like 80 times 5, or 6 times 320?
Mm-hmm. I think, well, I kind of knew that I was going to do long division this way when I started the year, so I think it definitely kind of colored the way that I taught addition and subtraction, because there was definitely a lot more emphasis on regrouping and like what regrouping actually means. And also it really impacted how I taught two-digit multiplication, because when they were doing, when you're multiplying, say, like 12 times 20, and you multiply by the 0, and you just get zeros, and you're multiplying by the 2, I really emphasize, like, what are you really multiplying by? And kids know now that they're actually multiplying by 2, which has a value of 20, because it's in the tens place. And so that 20 times 7, or whatever, would give you, 140 rather than just 14, and you just happen to put it in this spot, because that's what the algorithm has you do. So I think it really did, like, because I knew that I needed to get kids to this place, it really kind of impacted the way that I taught my other units, and so I think they really do have a much stronger value, understanding of place value, and just kind of like stronger number sense in that way. So I've definitely seen that it's like really impacted like how they do other operations as well. There's like really strong understanding of place value, and like what does it actually mean to have a 2 in this particular place in the number, and like why is a placeholder 0 important, things like that. I've usually had I had struggles like that last year with things like decimals, for example, like understanding the importance of a placeholder 0, and I feel like kids are in a better place this year. Because they kind of have this stronger understanding of place value.
Is there any other vocabulary or concepts that they understand better this year than when you taught long division with the kind of regular algorithm?
I'd say definitely the place value thing. I think there's also just a general sense that like everything that we do in a math procedure has some greater purpose, and that math is a lot of like representation of things. Like the idea that like the 2 in the tens place is a representation of 20. And I feel like kids kind of have an understanding of that now. And we've kind of talked a lot about how, decimals this year are like a representation of fractions that just look differently, but, have the same value. So I think kids have kind of like grown to understand like numbers as sort of a representation of values that may look different, but can have equivalent values even if they're like represented in different ways. So I think that's been cool.
Last question. When you taught this, it's pretty complicated,
Yeah.
and it's hard for even an adult to understand and when you first see it, but
Yeah.
I think it inherently makes a little bit more sense than kind of the traditional way to teach
Yeah.
long division, which in itself is complicated. Did you find that certain levels of students, either students with IEPs or things like that, had a harder time with this? Who did you find that it challenged? And who did it push, or was it just kind of like challenging for every student at the same time?
Definitely some kids with IEPs struggled with it, but actually who I was kind of, I think, pleasantly surprised to found it most challenging were the kids who came in with a really strong sense of how to do long division using the traditional algorithm and felt very confident using that algorithm, And, you know, we're regularly getting accurate answers using that algorithm, but we're now being pushed to like think about long division in a new way and think about what it really means when you know, bring down the 6, you know, because like in the traditional algorithm, it doesn't really mean anything, at least in the way that we were taught it. And so it really pushed like the medium, high, and high kids who were used to just kind of coasting with it and, you know, had kind of learned it and mastered it and they were done. And so now they're having to like really understand like what it meant when you had a, you know, 6 in this place and what are you really multiplying by here and so on. So I thought that was really cool. It really pushed those kids, and a lot of those kids actually struggled more than some of my lowest kids. The lowest kids, especially those who hadn't learned long division before, I think really latched on to like the set of repetitive questions that I gave them as they were doing long division. And I think what also really helped those kids especially is it gave them an opportunity to kind of really see when something was off. Because I guess you'll see, and maybe it would help when we do it with kids if they make some mistakes and they can kind of like pick out like that you actually know when you're wrong, because like this algorithm just won't let you like continue on with a mistake. And so that really helped them a lot. So, yeah.
So it's fair to say that students who traditionally struggle with math had an easier time with this presentation of long division than they did when you taught it the kind of traditional method.
I would say so, and especially those kids that might normally get lost in a very like complicated procedure. Like I had some kids who, or one student particularly who struggled last year with long division and just kind of, you know, was applying steps randomly and so on, and like this like more procedural, I guess more sensical method like helped him a lot. So yeah, those kids who kind of would just get overwhelmed with the numbers of steps and not really understand why you were bringing something down or multiplying here or subtracting, like it made sense to them, so they were able to apply those steps more accurately.
Perfect.